in 9.4, this is a continuation of what we did in 9.3, which was graphing rational functions. But now we're going to look at some more complex examples. Okay, so we graphed reciprocal functions, which are rational functions, in our last section, 9.3. Okay, but today we're going to graph functions of the form f of x equals a of x over b of x, okay, which is going to be two expressions. Okay, so that's where a of x and b of x are polynomials. And then, of course, when you have a fraction, whatever is in the denominator, that cannot be equal to 0. So there are going to be several things that are the same. Okay, so if you have this as your form, one thing that's going to be the same is the vertical asymptotes. So you might remember that we found those by taking the denominator and solving for x. So because they're using this form, they're just calling the denominator b of x. So b of x is equal to 0, and you solve for x. Okay, but just know that b of x is going to be the zeros of the denominator.
I know it's wrong, but I forgot my AirPods in my second option.
Okay, so for number 1, okay, I want you to find the zeros of the denominator. Okay, so let's try that for part A. Okay. All right, and then something that is going to be added on are finding the zeros, which technically we did because remember, zeros are x-intercepts. So when you are finding a 0, you just have to set the numerator, which they're calling a of x. So when you look at the book, they're going to say set a of x equal to 0 and solve for x. Okay, when I talk about this with you, what I'm going to say is you set the numerator equal to 0 and solve for x. Okay, and then again, zeros are the x-intercepts. Okay, so now I want you to do that for this example. Okay, so you already found the vertical asymptotes. Now I want you to find the zeros. Okay, for part A here. All right. So the next thing we're going to do is learn about horizontal asymptotes in this form. So in our form before, okay, all we had to do is find the value of k. We've already looked at this for a little bit now, so you can see there's nothing added on the outside. That doesn't mean that there's no horizontal asymptote, because this form, see how you have x minus 2 on top? With the ones we had before, do you guys remember what we had on top? It was just a number, okay? So now that's why it's a little bit different. Okay, so the horizontal asymptotes, those are a few rules. And when you're working on this on your own, okay, there are 3 different things here. You have zeros, you have vertical asymptotes, and then you have the horizontal. So each one of those is going to be a little bit different. Okay, so with the horizontal asymptote, it's all about the degrees. Okay, so it says the degree of A, and then I made a whoopsie because when you take pre-calc next year, you'll see instead of A, they don't call it A, they call it P. And so I wrote P by accident. So this book calls it A and B. Most textbooks call it P and Q. Not that that's a big deal or anything, but just so you know. Okay, so if the degree of A is greater than, okay, so greater than the degree of B, then we have a certain rule. If the degree of A is less than the degree of B, then we have another rule. And if it is equal to, we're going to learn the rule for that. Okay, so I just want to emphasize again, this is all about the degree of A, the degree of A, the degree of A. And every single time you are comparing that to the degree of B, the degree of B, the degree of B, then your horizontal asymptote is, okay, so if the degree of the numerator is greater than the degree of the denominator, then the horizontal asymptote is non-existent. So we're just going to say is none. Okay, and this is if the degree of the numerator is greater than the degree of the denominator. Okay, and then for the next one, okay, if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote, our good friend, y equals 0. All right, and then the last one is special. If they're equal, we get to do a little calculation here. So if the degrees are equal, numerator and denominator, it's best to look at an example so that you can understand how this is going to go. So let's say you have f of x equals 2x plus 1 over x plus 1. Okay, the way that you find it is you look at the leading coefficient of the numerator and the leading coefficient of the denominator, and you make those a fraction. Okay, so in the numerator, okay, the coefficient, the leading coefficient is going to be 2. Okay, so you would have y equals 2 over, and what's the leading coefficient in the denominator? 1. So it's 2 over 1. So it would be y is equal to 2. So the way that we say that is y is equal to the leading coefficient. So we'll just say the LCO of the numerator over the LCO of the denominator. All right, so based on that, I want you to look at that and see what you have there. Okay, thank you. Yep. All right, so for part A, that's what I want you to look at is the degree. So is the degree of the numerator greater or the degree of the denominator greater? And do we need a refresher on how to find the degree? Okay, so then after you compare the degrees, the numerator is less than the denominator, so I want you to write what that horizontal asymptote is. Okay, so the numerator is less than the denominator. What is that horizontal asymptote going to be? And once you've done that, I want you to just plug that into your calculator. Okay, so we're going to plug in x minus 2 over x squared minus 1. Okay, and you have to put that in a certain way. Remember, you got to have your parentheses. They may ask me to take their quiz. All right, let's see how we did. All right, so I asked you guys to find a few things. So I asked you to find the zeros and the vertical asymptote. Okay, so when you find the zeros, okay, that is the numerator equal to 0, and then you solve. Okay, so if this is a 0, remember that is an x-intercept. Okay, so you guys found x was equal to 2, and the way that we're going to write that is as your x-intercept. Okay? So again, when you guys found the zeros, you found that x was equal to 2, and you solved. All right, and then you guys also found the vertical asymptote, which is where you took x squared minus 1 is equal to 0. Okay, and then when you have x squared minus 1 equals 0, there's two ways you can do this, okay? You can factor, okay, and when you factor, you're going to get negative 1 and 1, or did some of you move this over and take the square root? Okay, so if you did x squared is equal to 1, just remember you got to have the plus or minus. Okay, so if you forgot the plus or minus, that's okay. We're going to add that part in now, okay? So you need both. X equals negative 1 and x equals 1. Both of those are vertical asymptotes. Okay? Now, something that I wrote up here is that graphs can cross a horizontal, but they won't cross a vertical. So in the ones we did before, the reciprocal functions, they don't cross either. But now we see that they are not going to cross a vertical asymptote. So it's not going to cross those. And then the last thing I asked you guys to find was the horizontal. Okay, with the horizontal, if you're looking at these, you have x minus 2. Okay, x minus 2 has a degree of 1. X squared minus 1 has a degree of 2. Okay, so the degree of the numerator is going to be less than the degree of the denominator, which means you follow rule number 2, y equals 0. Okay, and there are times where in this form it can cross the horizontal. I know that that didn't happen in 9.3 because that was a different type. Okay, so we found the zeros, we found the asymptotes. Now we are going to graph with a table. Okay, as you remember, we want the middle of our table to be the asymptotes. So if you have more than one, we're going to have to do a few different branches. Okay, so we have x minus 2 divided by, and then I would put this in as x squared minus 1, not the factored form. Okay, you do need parentheses around each one because they're binomials. Okay, and then when you are doing your table, you are going to plotting several points there. Okay, so we're going to go to our table set. I'm going to go to 0. Let's just go by ones to start this off, and then we are going to look at a few things. Okay, so when you see error where the asymptotes are, that is a good sign. Okay, so you have, when you have the x equals -1, that's an error. That is your asymptote. So we're going to look at what's happening on that side. Okay, so leave some room because we are going to keep doing the halves like we have been. We have -1.3 there at -4. We have -0.4. Okay, and then I'm just going to go by halves now and check out what's going on close. So at -1.5, I'm at -2.8. All right, so let's put our asymptotes on our graph. All right, so I have -1. I have 1. Okay, and then I have y equals 0. So I'm going to just label those. X equals -1, x equals 1, y equals 0. Okay, and then I'm going to start plotting my points. So at -1.5, I'm at -2.8. So I'm almost to 3. Okay, at -2, I'm at -1.3. At -4, I'm at -0.4. Okay, so see how with those 3 points I can create my curve. Okay, you can also look at your graph. So you can see how many branches do I have here. I have 3 branches now. Okay, so with the reciprocal functions, you only have 2 branches. Okay, sometimes you're going to have more than that here. So I'm going to have to find this branch in the center and then this branch here. Okay, so I'm going to go back to my table. So now for my next branch, let's do negative half, 3.3 repeating. At 0, I'm at 2. And then see how at 0.5 I'm at 2? See how that's kind of strange? Because we aren't going to have something that's flat, right? So how can I figure out what's happening in between there? Yeah, let's just change the table set. What could I go by? Yeah, let's go by a 4. I like that suggestion. Okay, so just going to go back to negative 1 so I can see what's happening. Okay, so at negative 0.25, I'm at 2.4. And at 0, I'm at 2. At 0.25, I'm at 1.86. Okay, so it's going to dip below there. At 0.75, I'm at 2.8. So that's going to help me create this curve here. Okay? So in between those, 0.25 is going to be 1.87. And then we use 2.86 to kind of get that other part there. All right, and then with the last one, 1.5, I'm at negative 0.4. At 2, I'm at 0. Okay, and then can see we have these points going up here. Okay, so at 1.5, I'm at negative 0.4. Okay, at 2, I'm at 0. And then at 3, I'm at 1.25. And you can see, right, these numbers are going up. At 4, I'm at 0.13. Okay, so remember what I said. Can you cross a horizontal? Yes, and you do. Okay, that's why you have the 0 here. And then this is going to follow. You will not cross a vertical. Verticals you will not cross because it's excluded from the domain. Okay, it's not allowed. Okay. And then I just asked you to think about this. So when would a graph have no zeros? Okay, so if you're solving for, we'll call it g of x. Okay, if you are solving for the numerator to find the 0, okay, what if you had something like 5 over x squared minus 1? If you set the numerator equal to 0 and you had 5 equals 0, would you be able to solve for that? No. Okay, so in that case, you wouldn't have any zeros. Okay, another case that I mentioned above here is if you get an imaginary value, it does not exist on the graph. So that's important to know as well. If you get an imaginary value, it does not exist on this real graph that we're doing. Okay, so that would be something like, let's do another one. Let's say you have h of x equals x squared plus 1 over x minus 1. Let's say you have that. Okay, if you were to set the numerator equal to 0, this would be imaginary because you would take a square root of what? A negative. Okay, so x would be plus or minus 1i. Okay, if it's imaginary, it does not exist on the graph. Okay, so both of these cases, no zeros. Okay, imaginary does not exist. And if you don't have a variable to solve for, okay, then there's nowhere to go from there. All right, so for part B, I want you to find the zeros, the vertical asymptote, and the horizontal. Okay, so zeros, vertical, and horizontal. And we're going to graph that part together. In order to find the zeros, Calvin, what do we have to do first? So what did you set up for that? That'll be for the vertical. For the zeros, it'll be setting what equal to 0. So for the zeros, you set the numerator equal to 0. Yeah, so you have the x cubed. And then how do you guys solve this if you have x cubed equals 0? Cube root. Okay, so the cube root of 0 is 0. Okay, so that is your x-intercept, 0, 0. Okay? All right, and then for the vertical asymptote, that is where we take the denominator and we set that equal to 0. So you can factor out the 2 if you want, or you can subtract and divide. Either way, you'll get x equals negative 1. That's the only vertical asymptote we have for this one. All right, and then for the horizontal, you compare the degrees. So, Riley, what's the degree of the numerator? 3. Haley, what's the degree of the denominator? You know the degree, though. Remember, the degree is just the highest exponent. Yes. Yep. So the degree of the numerator is greater than the degree of the denominator. I know it's been a while since we talked about that. We did that, I think, in chapter 3 or 4. It's a little bit ago. So once you compare the degrees, okay, use your rules. If you have the numerator is greater than the denominator, there are no horizontal asymptotes. Okay? So I asked you guys to graph in your graphing calculator, and we're going to set up our table. Okay, and when you're setting up your table, remember, you're going to have these different branches. You can always separate by the horizontal, or not horizontal, sorry, the vertical asymptote there. All right, and then when you're setting this up, if it's just one term, nothing added or subtracted, then you can leave it without your parentheses, okay? But if you have a binomial or greater, you are going to have to put parentheses in there. All right, and then we can look at our table set. And if you want to look at that, so it goes by ones first, you can. Okay, so at -1, you should have an error. I like to check that first and make sure I have that. Okay, so at -2, I'm at 4. -3, 6.75. Okay, and then I'm going to go by 0.5s. All right, and then I'm going to look at a few on the other side. So at -1/2, I have -0.125. At 0, I'm at 0, which I already knew. At 1, I'm at 0.25. 2, I'm at 1.3. Okay, so then you guys are going to set up your scale. Just like you would on your graph paper. Okay, so you have your Y. Really, you don't have a lot of negative values, so set that up. I chose to go by ones. All right, and then we're also going to look at our graph so we can see what shape we have. Okay, so this is an interesting shape here. Make sure you graph it so you can see what it's going to look like before you start plotting your points here. Okay, so I'm going to plot -3, 6.75. At -2, I'm at 1, 2, 3, 4. And then at, oh, sorry, I like to plot, I forgot. I like to do my asymptotes first, but I didn't. And then 1.5, I'm at 3.375. This is the only one I have here. Okay, and then sometimes I just like to see what happens. Again, if I go by the 0.25s, and I can see what's happening at -1.25, so that can help me with my shape. So sometimes I just add that in, even if it's not in order. So I can see it's going back up to 4. So then the shape of your graph, this is going to be the curve. Remember that it never crosses a vertical asymptote. Okay, so I have my points there. And when you guys are graphing, I do need to see your points, okay? Don't get messy on me. So have your specific points plotted. Okay, and then here at -0.5, I'm really close to the line, and then I have 0, 0. I have 1.25, which is about 1/4, 1 1/3, 3, I'm at 1, 2, 3.38, and 4, I'm at 6.4. Okay, and then you can see too from your graph that this is going to be going downward. Make sure, again, This is not going to cross the vertical. So you have a curve here, going to curve that up, and that is going to be going downward. Okay, and this one goes to -10. I only made mine to -2. Okay, you can make yours longer with that. Okay. All right, so for today, I'm going to give you 5 questions to work on. They have to be on graph paper.